Thank you, and thank you so much for bearing with me despite the technicals before and escaping to having coffee. All right, so I think a lot was said throughout the conference and a lot was said also before about this panel. Today, I'm going to take you through a concept, right? So future is unpredictable, and yet every business, every organization, every nation still thinks that they need to look forward. They need to anticipate and understand, what's going to happen next, which is normal. You've got to look into the realms of the possibles to be able to make choices and take decisions. And today, what you're going to be seeing is a short overview of the Airbus vision of what is required in terms of evolution of our systems when it comes to the new context of the rapidly evolving modern defense. So looking forward, what do we expect? What we're going to be exploring together today is what are the forcing changes that we see in our operational environment and in the threats to space that are going to be driving the way we as Airbus and generally we as an industry think about the systems that we're building and designing. The second point that I will touch upon, but I'll be brief on this because the panel before was amazing, will be what are the main threats to space, but that, we'll keep it short. We'll just add a couple of things and that'll be fine. Based on that, we will define what the key word is for the systems that Airbus is designing in the future, both for space and underground. And that key word is resilience, and we'll explore the resilience concept together. And the last part will be me taking you through the key technologies and the key features and trends that we as Airbus are looking at to reach said resilience. So if we look at the future operating environment, actually this is something quite classical. You've seen it thousands of times. This is the overall system. Everybody works together, and so on and so forth. But actually, what is going to change are the areas in the blue dot. Well, technically, everything is going to change. What we see in the future in terms of operating environment is the emergence of urban warfare, which has an impact on both the way you're going to be conducting your operations from a comm standpoint, because as we all know, the environment is not really easy to communicate, but also on Earth observation and the way we deliver the data. This new operating environment generates a lot of need for real-time intelligence because it changes rapidly, which will have an impact on the way we design our technical solutions, but also on the way we route our data or on the way we interpret our systems. The second big trend that we see is the emergence more and more of airborne connectivity, both manned and unmanned, which with the emergence of uncrewed hypersonic platforms and swarm tactics that will overwhelm traditional defense, will have an impact on the need for allies to have a blend of capability when it comes to communication around sovereign, allied, and commercial comms to offboard their ISR data, but also to manage status and missions in a contested environment. Another tendency that we see is the emergence of ISR based, so airborne and space-based is already here, but by the 2040s, what we foresee and the stuff we're investing on is a federated single intelligence enterprise that will process and exploit the EO data and disseminate them across the field using SATCOM, and actually our ability to connect and fuse data will be key in the future. And the last one, which is, I think, the most interesting one in terms of the technological changes it will bring to our environment is the concept of the transparent battlefield. I don't know if that's something that we've discussed upon today in details, but because anti-access, area denial technologies, and also just more generally ISR technologies will be way more mature, done into the end of the 30s and 40s, it will have an impact because military forces will be more likely to be visible, more likely to be trackable, which will cause a lot of troubles for our customers and ultimately for our nations when they want to conduct their operations. Based on those concepts and on the threats that you see here on the screen, which I will not go into more details because they were described before, what we understand now is that this quite gloomy future picture leaves us with a very strong need for resilience when it comes to defining our systems. Now, resilience can be an empty word, right? we've been discussing it every day. And actually, if I was to ask this question to people in the audience, like, how would you define resilience? I'd probably get something like 10 or 15 different answers. So for the sake of this presentation, let's try and define it as the ability of a system to continue to deliver its operational service when one or more than one threats are acting on the system. And the way to achieve that resilience is actually through responsive measures to restore the service at an acceptable level. In order to do this, we have defined a concept based on those four pillars that you see here: reliability, robustness, redundancy, and reconstitution. And this is the way that we define today and that we structure our general architecture at Airbus Defence and Space. We'll explore in a second what it means. So reliability, it's quite simple, and actually, in all fairness, all systems should be operating like this. Reliability is the ability of any physical node of any system to deliver the performance under a no-threat environment. So it's basically, have you delivered to your customer what they want? Full stop. Robustness is the ability of any node of said system to keep on operating or restore operation even under stress or under stress condition, be it adversarial or natural threat conditions. Redundancy is then the availability of alternate nodes that are able to replace any node of the system that's malfunctioning or having an issue. And reconstitution is the ability of all the nodes of the system, or the system itself, to rebuild service, reestablish service as a response to failure, or actually preemptively change its configuration to get back to the right state because it anticipates a threat. I mean, the example before with the sound is actually a good one in terms of illustrating reliability, robustness, redundancy, and reconstitution. So what we have done in Airbus is we've actually decided to look at this from two angles. Reliability and robustness are two things that you have to have in your system. At the resource level, the resource being either your spacecraft, your ground station, your ground segment, and so on and so forth. The redundancy and reconstitution has more to do with the way you design and you build your system in order to achieve what you want to do. Now, what are the technological trends and the specificities that we're investing on for each of those areas going to look like in the future? You can see here. So at resource level, where Airbus is investing is into those 5 areas that you see here on the screen: sense, protect, defend, survive, and extend. Sense is the ability of our systems to detect, track, monitor, characterize, and attribute objects and effects to actors in space. So we've been discussing this before, but it is really important when we want to manage our systems in the future and be resilient to be able to understand who's coming my way, who is that, what's it doing, and what am I going to do with that. The key technology here that we are exploring and investing on are around the SSA, SST type of features, bundled with AI and machine learning. The second is protect. Protect is the ability of the resource assets, satellite ground station or whatever, to protect themselves. It could be something coming my way, I want to enter into an evasive maneuver for the spacecraft. It could be, I'm anticipating some interferences, let's just shut down. But that's the typical type of features and capabilities that we are able now to onboard onto some of our assets, spacecraft or on the ground, to be able to deliver the effect that we have been discussing before. Survive. So survive is our ability to withstand pressure, mainly electromagnetic, so jamming and that sort of stuff. And we mainly have invested into capabilities in this area around protected waveform with specific modems and specific waveforms that are able to deliver the effects that we are requiring. Extend. Extend is the ability to extend the life of very expensive assets, because obviously cost is a driver we've been discussing throughout the conference, but how do you make sure that something that you've paid a couple of hundreds of millions stays up in the air? If you can refuel it, that's even better. And the last one is defend. So I've heard it mentioned briefly here about the fact that the French announced that they're looking at the Bodyguard satellite. It is something that we are considering, and we're considering the way of bringing something in orbit that is able to perform 5 specific missions. The first mission being detection, the second being deception, the third one, deterrence, The fourth one, denial, and the fifth one, if we come to this, and under the decision of the authorities, defense. Now, if we look at system level, what are we looking at? We're looking at three areas that we think are critical to the future of any architecture in space. The first one is connect. I think throughout the conference, this is a theme. Like, how do you disaggregate your capabilities across the multi-band constellation vendor architecture? How do you make sure that you have the good blend of sovereign, allied, partnered, or commercial capability in different types of orbits to be able to reach that sweet spot of resilience? This will be enabled by key technologies, open standards, and things like this. It will also be enabled by the second element of this, which is process. Process is finding a way to have on board of satellites both transparent and regenerative payload that are able to support switching, routing, and the overall dynamic agility of the network that we want to build in the future. This will be made possible by finding a right way to interface optical and RF. Currently, there's no standard for that. And it will also be done through specific investments into waveforms and capabilities like we're doing in Airbus today. And the last one is the dynamic adaptation. So that one's my favorite, mostly because it's still a bit blurry, and this is also where we are putting the most efforts. It's how do you find the sweet spot of building your system of system or your network of network that will be able to use all of the nodes of the system in a dynamic way, but also to change the system in a dynamic way as well, while managing, and that's the tricky part, encrypted traffic going through. So that takes us to this, which is a nice picture of what this overall architecture may look like and the key components of it. And that takes us as well to the last slide, which is the roadmap of our developments in terms of R&D/T in getting to where we need to go to bring those capabilities to our customers and partners. As you can see today, some of the capabilities are already existing, like inter-satellite links or anti-jamming features. Some more near-term, we're getting there, like SDA or some of the SSA's capability. The bodyguard is also on its way, and some of them are like more down the future. As I'm going to be short of time, and I'm sure you may have questions, I'll tell you that this image is a very short overview of what we think the future is going to look like and the way we're going to be designing our systems. But actually, the image, I must admit, is incomplete. And the main reason why it is incomplete is because we've been focusing today more on connectivity, on communications. But what actually is also on our radar, and we've been working on for quite a while now as well, is how do you blend the two main words that weren't talking that much together before, Earth observation and connectivity? How do you find a system that does both? Because ultimately, in the future, what is going to be relevant is getting the right information at the right place, at the right time, whatever the bearer, whatever your network, to enable a very, very fastly evolving operational environment. So that gives us a good topic for next year, probably. And I think we have 1 minute left, and I'm willing to take, therefore, one question, if that's allowed by the chair. The chair says yes. All right. So I've either been super clear, or you're all tired, and nobody actually understood what I said. Okay.
Don't be shy.
Clear it is, I think. All right, in any case, thank you all. If you have any questions, please reach out to us. And you can also come to our booth if you have additional questions that you want to raise. Thank you.